In this video, we are going to talk about writing equations, interpreting equations, and also systems. This video also is going to cover the problems on your assignment, but it may jump any duplicate problems for some briefness instead of making this a super long video. So let's go ahead and get started. So the first problem on the assignment is going to just slowly ease us back into writing equations. One of the things that I need when I write an equation is the slope of a line. So remember to find the slope of a line. We are finding the rise over the run. And when I have a picture, I can draw that in. If this is 0.1 and this is 0.2, to get from 1 to 2, I'm going to rise 2 and run 1, 2, 3, 4, 5, 6. So my fraction will look like this. Positive 2 because I'm going up, positive 6 because I'm going to the right. Now remember, I always simplify slope. I reduce it. 6 and 2 are both divisible by 2, so in order to reduce, we divide them both by 2, and I end up with 1 over 3. Now, secondly, if I'm trying to find a slope through points, I'm still trying to find the same thing. I'm still trying to find the rise over the run. But in order to do that, I'm going to use an equation. So the equation I'm going to use is y2 minus y1 over x2 minus x1. Finding the difference in my y values and finding the difference in my x values is finding that rise and run. In order to use the formula, I have to decide which is x and which is y. So this is x, this is y, my first point, this is x, this is y of my second point. Let's go ahead and plug it in our formula. 8 minus negative 4 and 8 minus negative 7. And I can type that into my calculator. So here we go. I can even type it in all at once. So 8 minus negative 4 and 8 minus negative 7. And I'm just going to do a quick check to make sure I type that in right. Yep. And you'll notice that I have 0.8. Now, we always like a rise and a run in case we have to graph. So I'm going to change it to a fraction by clicking this button over here. So 4 over 5 is what my answer reduces to. And that would be my answer. Now, the next question starts talking about these equations. So please write an equation of my line in slope-intercept form with the y-intercept of -3 and a slope of 2/5. So the equation for in slope-intercept form of a line is y equals mx plus b. Now this is a template where y always stays and x always stays, but I'm going to replace the m and I'm going to replace the b. So in order to decide what goes in the right spot, I need to know what m stands for. M stands for the slope and b stands for the y-intercept. So if I read this problem, I literally am going to take the y-intercept and plug it in here and take my slope and plug it in here. So what is that going to end up looking like? Y equals 2 over 5x, and either plus a -3, or we can reduce this, make it look more simplified. So 2 over 5x minus 3 would be the same thing. The next question is going to ask me to first write the equation, then graph it. So the equation, so y equals mx plus b. So there's my m. So y equals -2, 1 over 2, x, and my y-intercept is -5. Now, in order to graph, I'm going to go ahead and first plot a starting point, which is my y-intercept. So I'm going to go to -5 on my y-axis, and then I'm going to graph my slope. Now, you'll notice that I put the negative with the top when I rewrote my equation. Having it out front and having it just with the top are equivalent. They're equal. I can only put it with the top or only with the bottom, not with both. So just be careful of that. So what does that mean? I'm going to, my rise is -1. So instead of going up, I'm going to go down, but I still go to the right. So down 1 and over to the right 2. Use your line tool over here to connect the dots. And I have my line. The next question, and I think the next couple are the same, are going to ask me to use this table in order to find my y-intercept and my slope, and then my equation. Remember, I'm going to plug in my slope next to x and my y-intercept after the fact. So let's go ahead and talk about how do we identify those in our table. Now on a graph, the y-intercept is on the y-axis where that squiggly line is. Any point that I plot on it, the x value is going to be 0, and my y-intercept, or my point, is where however high it is. So if this was up 2, I'd say that's 0, 2. Now, how does that help me find my y-intercept on a table? Well, was the x value. So I'm going to my table to find where that x value is 0. This right here is the ordered pair that's going to tell me what my y-intercept is. My y-intercept is the y value, so -5. My slope. Remember to find slope. We can either graph this, or we can use the formula that says y2 minus y1 over x2 minus x1. Go into my table. This is the x row, so this is x1, this is x2, this is x3, x4, x5, and likewise this is y1, y2, etc. Now, as I look through this table, excuse me, I personally like to work with positive numbers. So in order to make this easiest on myself, I know I only need 2 points to make a line, so I'm going to cross out all of these with negatives, and I'm going to let this be my first point and this be my second point. And kind of pretend like those other ones aren't there. And because the pattern always stays the same in my table, this is legal. This is going to give me the right slope. So in order to find my slope, we're going to plug in some numbers. So y2 is 4, y1 is 1, x2 is 3, x1 is 2. So simplifying, 4 minus 1 is 3, 3 minus 2 is 1. My slope is 3 over 1, which just reduces to a 3. So slope is 3. So what does my equation end up being? Y equals 3x. My slope goes next to x. It's my rate of change. So that's what I need to be changing by. And then minus 5. And that would be my answer for my equation. Okay, let's look at a word problem. Okay, and kind of the same idea. This table is showing a pattern that's happening consistently. So it says, Chris to an escalator moving at a constant rate. The table below shows his distance from the first floor after different amount of time. So you get the idea that after 6 seconds, he's at 1140. So he's far away from it. After 9, he's at 1020, and then 900 at 12 seconds, and 780, at 15 seconds. So here's the first question. Question number 1 says, or part A, rather, what was Chris's distance from the first floor when he stepped onto the escalator? Now, how could I figure out what that is? Well, in order to figure out how far he was, I need to remember that what I'm trying to do is find out, and I'm going to continue my table this way. I want to figure out how far he was at 0 seconds, because 0 seconds mean he hasn't traveled at all. He's just where he started. So I need to work backwards. Well, to get backwards to 0, I notice that my pattern is that I'm adding by 3. I'm adding by 3. So to work backwards, I'm gonna do the opposite. So subtract by 3. 6 minus 3 is 3. 3 minus 3 is 0. And I'm gonna bring it over here so I can write some numbers. Now, just like when I continue a table going with the same pattern on the x values, I do the same thing on the y values. So to go between 1140 and 1020, I need to first know, is it that increasing or decreasing? Well, it's getting smaller. And by how much? So I'm going to take my handy dandy calculator, and I'm going to take 1140, and I'm going to minus 1020. And that's a change of 120. So that's decreasing by 120. So if I want to go backwards, I'm going to add 120. So 1140 plus 120, let's clear that, is 1260. So this is 1260, but that's only after 3 seconds. I need to go back one more time. So I need to add another 120 plus another 120 for a total of 1380. So how far is he? 1380. Now part B asks me to choose a statement that best represents or describes the distance from the floor. Now there's two options, 1 or 2, and I'm only going to choose one of them, and then I can ignore everything else underneath the other problem. So it says, as time increases, so times, if I'm looking this way on my table, going up 6, 9, 12, 15 seconds, that time is increasing. His distance from the first floor decreases. So is that true? As I go this direction, is it decreasing? And I say, hey, yeah, it is. So I'm going to select this option. I'm going to completely ignore this one down here, and I'm going to answer this question right here. So it says, at what rate is his distance from the first floor decreasing? Well, we decided that between here and here, it was decreasing by 120. Now, don't put 120 right there, because notice that the units is per second, and not 1 second passes, but I have 3 seconds that pass. So I'm going to divide that number by 3, which gives me 40. So the rate he's moving, he is decreasing by 40 centimeters per second. Let's just look at a second example to make sure we got the hang of that. Ravi is printing extra flyers to distribute. Flyers are printed at a constant rate, so the same amount for each time interval. The table below shows the number of flyers after different amounts of time. So notice it says extra flyers. So that means he probably has more than one flyer to begin with. So let's look at the first question. So choose which statement best describes how time and the number of Ravi have are related. So here are my options. As time increases, so as time is getting bigger, we're going this way in our table, 10, 15, 20, 25, that's increasing. The number of flyers Ravi has decreases. Was that true? 98, 133, 168, 203. That's not decreasing, that's increasing. So this option is wrong. I'm going to go with this one. Let's just double check. As time increases, positive. The number of flyers Ravi has increases, positive. Perfect. At what rate is the number of flyers Ravi have increasing? So quick math. So to get from 98 to 133, I'm going to do a quick subtraction. So 133 minus 98 is 35. So it is increasing by 35. Now that's 35 for 10 seconds. Per 5 seconds, pardon me. But I want and by seconds, I'm still on the last problem, I mean minutes. All right, no, we're good. So for 5 minutes. Now this says per minute. That means we're talking about 1 minute. So 35 by 5 and get 7 flyers per minute. So how many flyers does Ravi have when he started printing? Well, I can work backwards by 5 seconds. So at 5 seconds, he had how many flyers? So minus 35. And I want to go back one more space, so minus another 35. So I'm going to minus 35 twice. So 98 minus 35 minus 35. So 28. So how many does Ravi have when he started printing? He already had 28. So remember, these were extra flyers. Okay, let's look at just a few more examples. So on this next problem, we are going to be comparing 4 different functions. They're written in 4 different ways. Now you can see that on function 4, it's telling me what the slope and the y-intercept is. I can find those things from all of these examples. And let's just go ahead and take a second and identify them because we're going to need them. So on function 3, my slope is equal to 4 because that's the number next to x, and my y-intercept is equal to -4. That's the number on its own. And on these problems, I'd take a second and just write it down on a piece of scratch paper. Otherwise, as we answer each of these questions, we're going to have to recall. And I don't want you to have to recall, or recalculate multiple times. From a table, remember I find the y-intercept by looking for the x value of 0. So this right here is my y-intercept. So 3 is my y-intercept. To calculate a slope, we are going to take y2 minus y1, just like we did on that other table problem, over x2 minus x1. So let's go ahead and calculate that. I'm going to ignore these. So I like to ignore the negative values in a table. We'll call this x1 because it's in the x column. We'll call this x2 and y1 and y2. So let's go ahead and calculate. Plugging into our formula, we have 2 minus 3 over 1 minus 0. So 2 minus 3 is 1, -1, pardon me, and 1 minus 0 is 1. So that simplifies to -1. So here's my information for function 2, and let's figure out for function 3. So for function 3, my y-intercept is where it crosses the y-axis, the y-intercept, and I'm going to abbreviate that. That's what y-int is. It's an abbreviation for y-intercept. And my slope is my rise over my run. So from this dot to this dot, I rise 2 and run 1, which simplifies to just 2. So now that I have all of this information, let's answer my questions. So which function has a graph that has a y-intercept closest to 0? Okay, so I'm looking at each of them. Number 1 has a y-intercept of 5. That's pretty far. Let's see if there's anything closer. This one has a y-intercept of 3. That's even closer. This has a y-intercept of -4. Well, and while it's more negative, it's more spaces away from 0 than 3. So far, 2's winning. And then I jump to the last one. It says -1. So this is only 1 space away from 0. So 4. The next one says, which functions have graphs with slopes less than 3? And this is a select all that apply. So less than 3 slope. Well, 2 is smaller than 3. -1 is smaller than 3. 4 is not smaller than 3, so skip that one. And -3, yes, is smaller than 3. So 3 out of those 4 work on this one. Okay, part C says, which function has the graph with the greatest y-intercept? Let's go back and look at those y-intercepts. Looking around, looks like the greatest y-intercept is function 1 with a y-intercept of 5, and nothing else is bigger. So function 1. And that's how I answer those ones. Okay, my last couple problems are going to be talking about a few word problems, and they're going to be talking about a few equations. So it says Jane is a software saleswoman, and Y is her total pay. Okay, so if Y is her total pay, we're adding these two numbers to get her pay. X represents the number of copies of English is Fun she sells, and X and Y are related by the equation. So when I look at this equation, okay, if this is the number of books she sells, number of books, that means the number next to it, if this is how much she's going to get paid, the number next to it's how much the book is costing. The number that comes first is how much she already had. So the number on its own is always kind of my starting amount, or the value that doesn't change. Okay, and the number next to X is always like, what am I paying per something or for each something? It's my rate. So when I read the first one that says, what is the change in Jane's total pay for each copy that she sells? The rate of change, or how much her income is changing per book, is 110. So anytime you see this word change or this word each, we're looking for that number next to X, so 110. Then it says, what is Jane's total pay if she doesn't sell any books? Well, if she sold 0 books, 110 times 0 is 0. So it's that constant that's left over. So 1,700. Let's look at just a couple more examples to make sure we got the hang of this. So the next one says, scientists are studying a temperature on a distant planet. Y is the temperature in Celsius. X is the height above the surface in kilometers. So if we're measuring the height above the surface, okay, what's going on? So the number that's by itself is always like the starting amount. But let's kind of go backwards. So if it says, what is the temperature for the change for each kilometer, the amount it's changing is whatever is next to X. So notice that for an increase, we're using a positive number. For a decrease, we're using a negative number. So this is a decrease of 7 for each kilometer we go above the surface. So it's colder the higher we go. What is the surface temperature on the planet? Well, surface temperature means that I'm not going any. I'm going 0 high. I'm going to plug 0 into this height. -7 times 0 is 0. And my surface temperature is 41. The last problem on your assignment is going to look like this. It's a systems problem. And all it's asking is, okay, how many solutions and what are they? Remember, to be a solution, it's the point where they cross. So if I look at this graph, the only one that has just one solution is this graph right here, because there's just one point that they cross. And that solution is that ordered pair, the X and then the Y. So if I'm filling in my answer, I'm going to write -2 as the X value and +2 as the Y value. A and C are special cases. If I look at A, they never cross. So there is no solution. There's no one single point, or any point at all for that matter, where they cross. C, you'll notice L1 and L2. That means I have 2 lines stacked on top of each other. So there's not just one point that they cross. They cross at every single one. So this one has infinitely many solutions. All right, that's it for 4.3. If you have any questions, please reach out.